Good morning, my dear students. Today we are going to complete our lesson about introduction into complex numbers. This is introduction to complex numbers part 2. Okay, let's go. First, secondary, Algebra, Unit 1, Lesson 2, Part 2, Introduction to Complex Numbers, prepared by Mr. George Milad. Today we are going to talk about equality of two complex numbers. Two complex numbers are equal if and only if the two real parts are equal and the two imaginary parts are equal. So, if we have two complex numbers equals to each other, so the real part will be equal to the real part and the imaginary part will be equals to the imaginary part. Okay? So, if x plus yi, this is a first complex number, equals a plus bi, a second complex number. The two complex numbers are equal to each other. So, the real part, which is x, equals the real part in the second complex number equal a. So x equals a and the imaginary part y will be equals to the imaginary part b. And if x plus yi, this is a complex numbers, equals to 0. If the complex numbers equals to 0, this means that the real part equals 0 and the imaginary part will be equals to 0. So x equals 0 and y equals to 0. Okay? Example. Find the values of x and y in each of the following. 2x minus 3 plus 3y plus 1 equals I equals 7 plus 10i. Here you can see that here the first complex number is equals to another complex number. But the first complex number, 2x minus 3i, 2x minus 3i is the real part, and 3y plus 1 is the imaginary part. The imaginary part is the coefficient of I, and the real part is 2x minus 3. Okay, let's choose another color and try to solve the equation. Solution. Here, the real part, 2x minus 3, will be equals to the real part. So, 2x minus 3 will be equals to 7. So, negative 3 will go to the other side. So, 2x will be equals 7 plus 3, which is equals to 10. 2x equals 10, so x equals to 5. The real part will be equals to the real part. And the imaginary part, which is here 3y plus 1 equals 10. So 1 will go to the other side. So 3y equals 10 minus 1 equals 9. 3y equals 9. So y equals 9 divided by 3, which is equals to 3. So now you have x equals 5 and y will be equals to 3. The idea here that you have a complex number equals to complex numbers. So you have to put the first complex numbers in the standard form, which is equals to real part plus imaginary part. If a complex number is equals to another complex number, so the real part will be equals to the real part and the imaginary part will be equals to the second imaginary part. Okay? Solution. Here 2x minus 3 will be equals to 7. So 2x will be equals 10. And x will be 10 divided by 2, which is equals to 5. Here 3y plus 1 equals 10. 1 go to the other side. It will be 10 minus 1, which is equals to 9. 3y equals 9. Y equals 3. Okay. So x equals 5 and y equals 3. Another example. Here we have 2x minus 1, 2x minus y plus x minus 2yi equals 5 plus I. Here you have a complex number equals to a complex number. So the real part will be equals to the real part. The real part will be equals to the real part. So 2x minus y will be equals to 5. And x minus 2y, the imaginary part, x minus 2y will be equals to the coefficient of the imaginary part, which is equals to 1. These equations are two simultaneous equations. So we can solve it by using your calculator. Mode 5-1. Mode, you will choose mode 5 equation, then you will choose 1, which is solving two simultaneous equations. Or you can solve it by using your mind, as here we are going to multiply the second equation by multiplied by negative 2. So the first equation, we'll write it as this: 2x minus y equals 5 multiplied by negative 2, negative 2x plus 4y, negative 2 multiplied by 1 equals to negative 2. By adding 2x minus 2x will cancel each other. Negative y plus 4y, it's equals to 3y. 5 minus 2 will be equals to 3. 3y equals 3 divided by 3, y equals 1. Substitute again in the second equation by y equals 1. Now you have x minus 2. We are going to replace 1. We are going to replace y, which is equals to 1. Y equals 1. All of this equals to 1. X minus 2 multiplied by 1 will be x minus 2 equals 1. So x equals 3. Okay. So now you find the value of x, which is equals to 3, and y will be equals to 1. Okay. And you can see the steps of solution, but here I solve this equation by using calculator. Here when you write mode 5-1, he will ask you about a is the coefficient of x equals 2, b is the coefficient of y equals negative 1, c will be equals to 5, and in the other line a will be equals to 1, b equals negative 2, and c equals 1. If you press equal, the answer will be x equals 3 and y equals 1. Okay. Exercise. If 3x plus 2yi minus 9 minus x minus xi minus I equals 0, find x and y. Okay. This is one of the important example. Let's solve it together. Solution. Here you have to write the first complex number in the standard form. How can we write this complex number in the standard form? We all know that the standard form of a complex number consists of two parts, real parts and imaginary parts, and all this complex number equals 0. Here the real parts are 3x and negative 9. Those are the two real parts. Why? Because there is no I next to each of them. But the two imaginary numbers are, or the imaginary parts will be 2yi, negative xi, and negative I. So here we will write I in front of the bracket to say that this is the imaginary part. Okay? So we will write 2y minus x minus 1 equal 0. In the previous very important remark, we know that if a complex number equals 0, so the real part will be equals to 0. So we can write 3x minus 9 equals 0 and 2y minus x minus 1 equals 0. Okay? 3x minus 9 equals 0. So 3x will be equals to 9 divided by 3. So x will be equals to 3. Here 2y will write it as it is. 2y minus x. Here x equals 3. So minus x equals negative 3 minus 1 equals 0. 2y minus 4 equals 0. So 2y equals 4. 2y equals 4 divided by 2. So y equals 2. So here you can find that x equals 3 and y will be equals to 2. Okay? Okay. You can solve this example again by yourself because this is an important example. Okay? Another example, another exercise. You can pause the video and solve it by yourself and find your answer. Okay? Let's go to another idea. Operations on the complex numbers. Here we are going to study 3 operations on the complex numbers: adding and subtracting, multiplying and dividing. So we are going to study adding and subtracting, multiplying and dividing. Okay, let's go. Adding. First, adding. Find in the simplest form 7 minus 4i plus 2 plus I. Here, to find the solution of this problem, it will be very easy. Here, simply you are going to add the real parts together and the imaginary parts together. So here, the real part is 7 and the real part is 2. So we are going to remove the brackets first. 7 minus 4i plus 2 plus I. Here 7 is the real part and 2 is the real part. 7 plus 2 will be equals to 9. Negative 4i plus I, this is equals to negative 3i. Very simple. Okay? So when we add or subtract two complex numbers, we add the real parts together and the imaginary parts together. Okay? Okay. Here 2 minus 4i plus negative 5 plus I. First we are going to remove the bracket, so it will be 2 minus 4i minus 5 plus I. Here the real part is 2. The real part here is 2. Okay? And the negative 5. 2 minus 5 will be equals to negative 3. Negative 4i, the imaginary part, and I, the imaginary part. Negative 4 plus 1 will be equals to negative 3i. Very easy example. Here again we want to add 3 plus 7i plus 5 minus 9r. Remove the bracket. 3 plus 7i plus 5 minus 9i. 3 the real part and 5 is the real part. 3 plus 5 will be equals to 8. 7i minus 9i will be equals to negative 2i. The last one. Here we want to find 1 plus 2i plus negative 3 plus 4i plus 5 minus 2i. Removing the brackets. 1 plus 2i minus 3 plus 4i plus 5 minus 2i. Here we are going to add the real parts together. 1 minus 3 equals negative 2. Negative 2 plus 5 will be equals to 3. And 2i and 2i. Here we have 2i and the negative 2i will cancel each other. And the remainder will be 4i. So the final answer will be 3 plus 4i. Okay. Second, multiplying. Find in the simplest form. 4 plus 3i multiplied by 2 minus 5i. Let's solve this together first. Here you have 4 plus 3i multiplied by 2 minus 5i. First, here you are going to multiply 4 by 2. You are going to distribute 4 on the two terms of the bracket. So 4 multiplied by 2 and 4 multiplied by negative 5i. Then you are going to distribute 3i over the two terms of the bracket, 2 minus 5i. Okay? 4 multiplied by 2 will be equals to 8. 4 multiplied by negative 5i, it will be negative 20i. 3i multiplied by 2 will be positive 6i. 3i multiplied by negative 5, this is equals to negative 15. But you have to notice that 3 multiplied by negative 5 equals negative 15. I multiplied by I. When we multiply, we add the powers. So I multiplied by I will be equals to I power of 2. But we all know that I power of 2 equals negative 1. Here 15 multiplied by I power of 2. So negative 15 multiplied, we are going to replace I power of 2 by negative 1. So it will be negative 15 multiplied by negative 1, which is equals to 15. Now here 8 will left over. Negative 20 plus 6, it will be equals to negative 14i. Here again negative 15 multiplied by negative 1, this is equals to 15. Okay, collecting like terms, here 8 plus 15 will be equals to 23 and negative 14i will left over. Okay, so the final answer will be 23 minus 14i. Okay, another example. Here we want to find 1 minus 7i multiplied by negative 3 plus 2i. Okay, first we are going to distribute 1 over the two brackets. So 1 multiplied by negative 3, here 1 multiplied by negative 3. This is equals to negative 3. Okay, and 1 multiplied by 2i, this is equals to 2i. Okay, negative 7i multiplied by negative 3, it will be equals to 21i. And here negative 7 multiplied by 2 is equals to negative 14. And I multiplied by I, it will be equals to I to the power of 2. Here again, we know that I power of 2 equals to negative 1. So we will replace I power of 2 by negative 1. So the answer will be negative 3 will left over, 2i plus 21i, it's equals to 23i. here negative 14 multiplied by negative 1, this is equals to positive 14. Here collecting like terms, negative 3 plus 14, this is equals to 11 plus 23i. Okay? So here the final answer will be 11 plus 23i. Okay? Another example. Let's erase the brackets first. Okay. Here, if 3x minus 2iy equals 5 minus I for all power of 2. Find x and y. Okay? Solution. Here, we will write the first complex number in the standard form. 3x minus 2y I equals 5 minus I for all power of 2. We are going to expand the bracket. This is a perfect square. So we are going to expand it by 5 times 5 equals 25. Here, first times second times 2, it will be 5 times negative 1 equals to negative 5. Multiplied by 2, this equals to negative 10i. Then negative I for all power of 2, this is equals to positive I power of 2. Okay? But we all know that I power of 2, this is equals to negative 1. So now we have 3x minus 2yi, this is equals to. Here I power of 2 equals negative 1. 25 minus 1, it will be equals to 24. Minus 10i. Okay? Here we have a complex number equal another complex number. So the real part will be equals to the real part. 3x equals 24. The imaginary part, negative 2y, will equal the imaginary part, which is equals to negative 10. 3x equals 24, so x will be equals to 8. Negative 2y equals negative 10. So when we divide it by negative 2, y will be equals to 5. So here x equals 8 and y will be equals to 5. Okay? And you can solve it again by using the PowerPoint. You can solve it by yourself. Okay? Let's go to another idea. The last idea is this lesson is to know the conjugate of a complex number. What is the conjugate of a complex number? We all know that 3 plus 4i, this is a complex number. The conjugate is of the complex number is 3 minus 4i. So, very easy. The conjugate of a complex number is to change the sign of the middle term. So if the complex number 3 plus 4i, so the conjugate of the complex number will be 3 minus 4i. And the conjugate of 5 minus 10i will be 5 plus 10i. You change the sign in the middle. Okay? The conjugate of root 3 plus 7i will be equals to root 3 minus 7i, and so on. Okay? So, here the two numbers a plus bi and a minus bi are called conjugate numbers. Okay? For example, 4 minus 3i, the conjugate will be 4 plus 3i. Example, simplify. 4 minus 6i over 2i. How can we simplify 4 minus 6i over 2i? Here, in these examples, we don't want to find I in the denominator. So the idea of these examples to get rid of I in the denominators. Okay? And to do so, we are going to multiply up and down by the conjugate of the denominator. So, in this example, we can solve it by using two ways. For solution, for minus 6i over 2i. Here you can multiply it by the conjugate of 2i. So what is the conjugate of 2i? 2i can be written as 0 plus 2i. So the conjugate is 0 minus 2i. So we are going to multiply it by negative 2i over negative 2i, which is the conjugate of 2i. Okay, this is the first method. But here you can see that negative 2 will cancel negative 2. And here we want to get rid of I, so we can write it in the simplest form as 4 minus 6i over 2i multiplied up and down by I. Okay? So, first we are going to solve the numerator. 4 minus 6i multiplied by I, we are going to distribute 4 times I, it will be 4i. Negative 6i multiplied by I, it will be negative 6i to the power of 2. And here 2i multiplied by I, it will be 2. I multiplied by I, it will be equals to 2i to the power of 2. Here in the denominator, I power of 2 equals negative 1. So 2 multiplied by negative 1, it's equals to negative 2. Okay, and in the numerator, here we have I power of 2, which is equals to negative 1. So for I, we're left over negative 6 multiplied by I power of 2. I power of 2 equals negative 1, so it will be 4i plus 6. Okay, here we are going to split the denominator, so we are going to divide 4 divided by negative 2, it will be negative 2i, and 6 divided by negative 2, it will be equals to negative 3. But this number, this complex number, is not in the standard form. You have to write it in the standard form, so it will be negative 3 minus 2i. Okay? This is the answer of simplifying 4 minus 6i over 2i. Okay? Let's solve it together by using the PowerPoint very quickly. Here 4 minus 6i over 2i multiplied by negative 2i over negative 2i. Okay? Here 4 multiplied by here negative 4 multiplied by negative 2i, it will be negative 8i. Negative 6 multiplied by, I think there is something wrong, and this solution is not correct, but the final answer will be okay. To negative 2i minus 3, and you can write it in the simplest form as a complex number, so it will be negative 3 minus 2i. Okay, here I solved this example by using the conjugate of 2i, which is equals to negative 2i. You can solve it by yourself. Distribute negative 2i multiplied by 4 and negative 6i multiplied by negative 2, and 2i multiplied by negative 2i, this is equals to negative 4. We can solve it together and correct it together. We are going to fix it. Here 4 multiplied by negative 2i, this is equals to negative 8i. Okay, and the negative 6 multiplied by negative 2, this is equals to positive 12i power of 2. Positive 12i power of 2. 2i multiplied by negative 2i, this is equals to positive times negative, it will be negative 4i to the power of 2. Okay? I power of 2 equals negative 1. So 12 multiplied by this equals to negative 12. So here we can write negative 8i, okay, minus 12. This is not positive 12, this is negative 12. Okay, negative 12. And here negative 8i. Okay, negative 8 divided by negative 4, it will be negative 4i. Here this is also is not negative 4 because we know that I power of 2 equals negative 1. Negative 1 times negative 4, this is equals to 4. Okay, this is not negative 4. Negative 8 divided by 4, it will be equals to negative 2, and the negative 12 divided by 4 will be equals to negative 3. Here you have to put it in the simplest form, in the form of complex number, so it will be negative 3 minus 2i. Okay, let's go to another example. Here we want to simplify 26 over 3 minus 2i. Okay, now you can see that you have 3 minus 2i, and we have an imaginary number in the denominator. So we want to get rid of the I in the denominator. So we are going to multiply up and down by the conjugate of 3 minus 2i. What is the conjugate of 3 minus 2i? Is 3 plus 2i. So multiply by 3 plus 2i in the top and the bottom. 3 plus 2i. Okay? Why? Because 3 plus 2i divided by 3 plus 2i, this fraction equals to 1. So we didn't change the problem. Okay, how can we multiply it? Here you can write 26 as it is and write 3 plus 2i. So this is 26 multiplied by 3 plus 2i. Okay? Then we are going to multiply the denominator. The denominators are 3 minus 2i multiplied by 3 plus 2i. These terms are difference of two squares. So when we multiply first by first, 3 times 3, which is equals to 9. Negative 2i multiplied by positive 2i, this is equals to negative 4i squared. Okay? 26 multiplied by 3 plus 2i will left over. Here I power of 2 equals negative 1. Negative 4 multiplied by negative 1, this is equals to positive 4. So we have 9 plus 4. 9 plus 4 equals 13. So you can cancel 26 divided by 13. 26 divided by 13, which is equals to, and 3 plus 2i were left over. Okay? Distribute the 2 over the two terms of the bracket. 2 times 3 will be equals to 6, and 2 plus 2i, this is equals to 4i. Or you can distribute 26 over the two terms of the bracket, then you are going to divide the two terms of the bracket divided by 30. Okay? Let's solve it again by using the PowerPoint. Okay? Solution. 26 over 3 minus 2i multiplied by the conjugate up and down. The conjugate of 3 minus 2i, it will be 3 plus 2i over 3 plus 2i. Okay? Here, 26 multiplied by 3, it will be equals to 78. And 26 multiplied by 2i, this is equals to 52i. Here, the denominators are difference of two squares. So when we multiplied, 3 times 3 will be equals to 9. Negative 2 times 2 will be equals to negative 4 I power of 2. I power of 2 equals negative 1. So negative 4 multiplied by negative 1, this is equals to 4. Okay? Now you have 78 plus 52I over 13. You are going to divide it. 78 over 13, which is equals to 6. And 52 divided by 13, which is equals to 4I. So the simplest form will be 6 plus 4I. Okay? Another example. Here we want to simplify 3 minus I over 2 minus I. So we are going to multiply top and the bottom by the conjugate of 2 minus I. What is the conjugate of 2 minus I? Very good, excellent. The conjugate of 2 minus I is 2 plus I. So we are going to multiply up and down by 2 plus I. Okay? Here we are going to solve the denominator first. 2I, 2 minus I multiplied by 2 plus I, this is a difference of two squares. First times first, 2 times 2 will be equals to 4. Negative I multiplied by positive I, this equals to negative I power of 2. And we all know that I power of 2, this is equals to negative 1. Negative 1 will be equals to positive 1. So this is equals to 4 plus 1. So in the denominator we have 4 plus 1, which is equals to 5. Okay? Let's multiply the numerator together. Here we have 3 minus I multiplied by 2 plus I. Here we have to put it in brackets. Okay? We are going to multiply 3 by the two terms of the bracket, and we are going to distribute negative I over the two terms of the bracket. 3 times 2, this is equals to 6. 3 multiplied by I, this is equals to 3I. Negative I multiplied by 2, this is equals to negative 2I. Negative I multiplied by positive I, this equals to negative I power of 2. Simplify furthermore. Here negative I power of 2, this is equals to, we know that I power of 2 equals negative 1. So negative 1, it will be equals to 1. 6 plus 1 will be equals to 7. And 3I minus 2I, it will be equals to positive I. So the result will be 7 plus I over 5. Here you have to put it in the standard form of the complex number. So we will divide 7 over 5. It will be 7 over 5. Here the coefficient of I is 1. So it will be 1 over 5I. This is the simplest form of this example. Okay? Okay. Let's solve it together by using the PowerPoint. Okay, solution. 3 minus I over 2 minus I multiplied by the conjugate 2 plus I over 2 plus I. Okay. Here you can find that we are going to distribute 6 plus I plus 1. This is equal to 7 plus I, and the denominator will be equals to 4 plus 1. This is equals to 5. Simplify again, it will be 7 over 5 plus 1 over 5 I. Okay? And this is the end of our class today. Thank you so much. Until we meet again next time, goodbye and good luck. استر يا رب. حتى كده يعني